So, okay. The first part of it is okay. Who knows what part of the brain constricts the pupil when you get a light reflex? It's what
quarter section of?
It's the Edinger Westfall. All right. So what we are testing, the first thing we're going to think of right now that we're testing when we do the light reflex is the Edinger Westfall nucleus.
Which lives in the midbrain.
In the midbrain.
Can you repeat that word again?
Edinger. Right on.
Thank you.
Well, Edinger.
I see it.
Okay.
Thank you.
So yeah, that's what I put on your sheet. I can't spell. So, all right. When you shine the light in, somebody's right eye. Okay. You're going to test for. You're testing that same side Edinger Westfall. Okay. What you're looking for is normal would be a brisk constriction. So not like super immediate, but basically you put the light on there and you kind of see it constrict. All right, that's normal. Normal is also, it should be able to hold that constriction for about 3 to 4 seconds. If you shine the light on there and you almost don't even see it constrict, it's just like bam, that means it was hyperactive. I mean, that thing's just like, whoa, constricting. If it either, one of two things, if it either has, we call that quick to fire. If there's quick to fail, so it constricts, but then it almost immediately kind of opens up, that means it's hypoactive and it wasn't able to hold the constriction. Or, we're not going to talk about the difference really right now, or if you see hippus, which is where it'll constrict, you kind of open up and constrict, it's trying to work, so it's also lesion.
How long did you say it would take to get out to it?
I've got it on the back of your sheets. About 3 to 4 seconds is how long it should last. Alright, so do we have any questions with that part of it? Alright, so what you're looking for as far as testing the Edinger Westfall is it a brisk contraction or constriction? Does it last about 3 or 4 seconds? If it's too quick, it's hyperactive. If it's quick to fail, hypoactive, or hippus, hypoactive. Now, we're going to talk about how to actually do the test. And this is difficult for a lot of people, but it's extremely important. So don't get frustrated with it. I'll put one of these on the back of your sheets, and you can use a pencil to practice putting lesions in different areas and kind of going through it like a maze and seeing, what the responses would be. So let's say this is the right side, this is the left side. Who can tell me first, what is the definition of an afferent signal?
One that travels from the brain to the neuron.
Say it one more time.
One that travels from the sensory to the...
Yeah, so it's a sensory information. It's something coming from the periphery and letting the brain know what's going on. So afferentation is sensory. What does that mean, efferent or efferent? It's usually, not always, usually it's a motor signal. So the brain, that means depending on what part of the brain or what the activity is, there's an area of the brain that's the processing center for that response. So whatever the signal is coming in, there's an area of the brain that processes it and sends out a proper motor action. All right, so now, here's what you're going to do. First, let's just talk about what the pathway is when the light goes through the eye. All right? So if I shine the light in to somebody's left eye, it's going to come up. Now, let me just go ahead and talk about this right now. You see a lot of people when they're doing the light reflex, they go lateral, medial like this, right? You see them coming in here like this. When you do that, it's fine, but you just need to understand that, just like we talked about with the visual field test, stuff that's coming from your lateral field of view decussates, more of the signal decussates over, right, to the other side. If you come medial, it's going to stay more ipsilateral. Okay? We just throw that so you see it could go both ways. That's where the chiasm is. But, so we're going to be doing the test. We're going to show you how to do the test medial to lateral. So the light comes in, stays on the ipsilateral tract, and it comes to the pretectal nucleus. All right? I've got all of this on the back of your sheet. All you have to think about the pretectal's job is simply to split that one afferent signal into two. So now you've got both Edinger-Westphals are getting that signal. Now we already said that the Edinger-Westphal's job is to constrict the pupil. Well, it constricts the ipsilateral pupil. All right, so this one's going to fire down and constrict this guy, and he's going to fire down and constrict this guy. So when I shine the light in somebody's eye, you're going to get bilateral constriction. Right? Does everybody follow that and see how that works? Are you sure? Because it's going to get more complicated. All right. Now, when you're actually performing the reflex, we have something that's called the direct pathway and the indirect pathway. The direct pathway simply means when you're doing the test, you're looking at the same eye that you're shining the light in. Indirect test means you're examining the opposite eye. You get bilateral constriction. Okay? So what you want to do is, you want to shine the light in this eye first. Well, it doesn't matter what side you start on, but it's probably best to do direct and indirect. Okay? The same. So you shine the light in, light's going to come in, hit the pretectal, come down to the Edinger-Westphal, and constrict the pupil. Does everybody see that pathway? When you're just looking at the ipsilateral eye. Okay? Let me go ahead and show you. No, sorry. I'm getting ahead of myself. Okay. Now I want to look at the indirect. So the indirect, I'm going to come over here and shine the light in the opposite eye and keep looking over here. So the light's going to go up this way, hit the pretectal, which the pretectal is going to split the signal over here, and now you get constriction. Does everybody follow that pathway? All right. Now you would come over to this eye, and you would do direct on this one, and then you would do indirect on this one. Everybody see how to do the test? Okay. Now, we're going to talk about how to figure out if it's
does it matter for if you're checking the Edinger-Westphal if you do medial lateral because it's bilateral constriction?
If you're just that, if you're doing it that way, if you know that everything's cool, you know what I mean? But if there's a problem somewhere, you may need to use one side or the other. Does that make, you know what I mean? All right. Sorry, sometimes I'll ask advanced questions, so don't worry about it. Okay, so what we want to talk about now is how to determine if you have an afferent block that's sensory, or is it an efferent problem? Okay? Now remember, so I didn't say this before, so this shows that since the afferentation comes into the Edinger-Westphal, and then the motor signal comes from the Edinger-Westphal, this is what? The processing center for the light reflex, right? Okay. So, why is it important to know if it's an afferent lesion or an efferent lesion? If you do your light reflex on somebody and you're like, man, that right pupil or left pupil, it's not even really constricting. I need to work on that, rehab that left midbrain. You start trying to ramp up that midbrain, and the midbrain is cool, now you're causing hyperactivity. The problem is that maybe the retina's messed up, and so the light just couldn't get back there. right? So now you're messing up a perfectly good midbrain like we talked about before. You gotta have the proper diagnosis. Otherwise, you're not only not gonna fix a problem, you might cause another problem. So,
You said, I'm sorry, you said now that the midbrain. Can you repeat that again?
yeah. So,
What was
we talked about that this is testing the midbrain, right? All this in here is midbrain. The prefrontal, the Edger-Westphal, it's all midbrain. So we just said the first part we talked about the quick to fire, quick to fail, all that's testing the midbrain. Now, if you shine the light in and you feel like it's not even really constricting at all, and you're thinking it's because this side's so hypoactive, the midbrain, that it can't constrict the pupil, you may start doing your rehab to strengthen it, but this wasn't the problem. The problem is somewhere over here, like I said, like maybe the retina's messed up, so the light can't even get back there. The cranial nerve 2's messed up, so the light can't even get back there. The problem is here, you gotta be able to determine where the problem is. Does that make sense?
This is where, well, after we're talking about like a physiological lesion, we're looking at neurons, this is more of neuron theory, like I said, where you're comparing one side to the other. They both work, but you're comparing is one side better than the other. With this, he's explaining how before you start, you're comparing one side to the other, you want to make sure you rule out, is there an ablative lesion? And is that nerve just not working at all to make it constrict?
Or it doesn't necessarily have to be ablative, because you can have an ablative lesion anywhere. It could just be that somewhere in this afferent pathway is hypoactive. It could be both. So let's look at what happens. I have them on the back of your sheets, but right now don't look at this side, don't look at the answer side. Okay? This red X represents a lesion. So right now we're just talking about an afferent pathway. So anywhere here, including the pretectal, all the blue is afferentation. So if I shine the light, I'm doing direct reflex. If I shine the light in this left eye, am I going to get a direct response? Is it going to close? Is it going to constrict? Is there anybody that doesn't see why it won't constrict? Because the light, bam, it's right there. Okay, so the light's not getting back there. Now, I'm going to do the indirect. So I do my light, direct. Oh, okay, well that didn't constrict. Let's do the indirect. I shine the light over here, but I'm still looking at the left eye. Is it going to constrict?
Yes.
So you will get constriction with the indirect.
Assuming
Right.
it's not damage to the afferent and efferent, but pathways in that room.
Do what now?
Assuming that there's not damage to both afferent and efferent pathways in the retina.
This, 99% of the time, you're going to have one major problem that's causing other problems. Right now, let's just think of this is your problem, or one major problem. All right. So you note that, okay? No direct, you do get an indirect. Now we're going to move to the right eye. We'll do direct on the right eye. Shine the light in. Will it constrict? It will. So now I got to do indirect over here. I shine the light in the left and look at the right. Will it constrict? No. Okay? So that is how you know that there is an afferent. Right now we're just going to say that there's an afferent problem on this side. Okay? Now, does anybody have any problems with that? Does everybody follow that?
I don't see the connection between the left and the right eye.
As far as, so like over here, well, pretend like this X isn't here. Remember when the light comes in, it goes up, and that pretectal nucleus splits it to both Edger-Westphals. So now they both have the signal to constrict. So they should both constrict with ipsilateral stimulation. All right. Now, and you'll see, step one is getting this down and understanding it. Step two is being able to see this in your head with a patient. So like Lauren was saying, you should, even if you don't think you need to, maybe just start going up to your friends and just start doing it and practicing, just so you can kind of get it down. Step three is being able to have in your head what answers am I going, what responses am I going to get for what lesions. So we said, so with a left afferentation lesion, we're going to get no direct on the left and no indirect on the right. Okay? So now we're going to go to what if there is a efferent lesion. Okay? I'm going to shine the light in the right eye, looking at the direct. Is the left eye? Is the left eye going to constrict?
Yes.
No, right? Because we're looking at the left. Light's going to come in, hit the pretectal, come down ipsilaterally. Boom, there's the lesion. So now it can't come down to constrict, right? Now I'm going to do the indirect. So I'm still looking at the left eye and I'm shining the light in this side. Is it going to constrict? Nope. Light comes up, hits the pretectal, it splits to this edge of Westfall, it's blocked again. Alright, so we know no constriction on direct or indirect. Come to the contralateral eye. Look at it directly. Is it going to constrict? It will constrict. Let's look at it indirectly. So shine the light in, still looking at this eye, will it constrict?
Yes.
Alright. Everybody got that in one shot. That's awesome. Alright, so you understand the pathway of how to, I think it says in our lab manual for neurodiagnosis that if there's a direct, you don't get a direct response, that means it's afferent, and if you don't get an indirect, it's efferent or something. Obviously, now you see that's not really true. It's a lot more intricate than that. But now you see how to tell the difference, okay? So step one, if there's a problem, you shine the light in. Now you need to do this to see, is it afferent or efferent? And then you know, so that you know whether this is the problem in the midbrain or if it's something in the afferent pathway. Is everybody cool with that concept? All right? Now,
could you real fast just explain, or just say, with the lesion in the edge of your Westfall and both, it's no constriction with direct or indirect?
all right, so for the left eye, you cannot get constriction direct. Indirect, you can't get it, right? So basically, the only thing that constricts, it's ipsilateral eyes and end of Westfall, so if it's a lesion, that eye is never gonna have, but now remember, if it's just a physiological lesion, they don't have a tumor, it might just be that it's quick to fail or, quick to fire if it's hyperactive. But then the other side, its end of Westfall is fine, and there's nothing over here in the afferent pathway, so it's gonna constrict direct or indirect. Okay? Now, raise your hand if you're in advanced. Okay, real quick, I think it was mentioned a couple of weeks ago. I don't want to go over anybody's head, so if it does, just kind of forget this part. But somebody was asking about it. Another way to further differentiate with the Edinger Westfall is doing the confrontation that we talked about, because confrontation and you get the accommodation, you get the constriction response. But that pathway comes straight from the cortex and it bypasses the pretectal nucleus and goes into the Edinger Westfall. All right, so that's how you use it to further.
So is that when you do the light reflex and you see it doesn't really constrict that well, and then you do a combination and you constrict perfectly, it might be pretectal.
And what you can do is, when you go in, you can have the light on there and then do the confrontation so you can actually see it. I don't want to talk too much about it because I don't want to confuse everybody. But is everybody, I just wanted to answer that. I don't remember who asked it a couple weeks ago. Is everybody cool with that? All right, here's what we're going to do. I'm going to show you how to do this, and we're going to practice doing it. All right, so what you're going to do is start here, just put the light down on the middle of their forehead, and you can see it, how bright it is. Remember, you don't want it to cross over. You can't let it cross the bridge of the nose. Put it on the forehead so you get the right amount, and then knock it over. Okay? And remember, you got to hold it there long enough to make sure, you know, if it's going to just keep constricting and it won't let go, that could be another hyperactive, right? I didn't say that before. So you need to hold it there long enough to see, you know, is it ever going to dilate again? Hold it there long enough to see what you need to see.
So you hold it about 2 to 3 seconds. It constricts. You should hold 2 to 3 seconds, and then it should come back out. That's the normal.
About 3 to 4, maybe a little bit longer.
Should it come back out to normal, like when it was before? Or
Basically, it's just meaning that it can hold it there for about 3 to 4 seconds before it starts.
Yeah, and then it should dilate again. Even though you're holding the light on there, because you should get used to it.
So I just wanted to show you, so remember, I just want to show you how to do it. Remember, you want to do the direct, and then still looking at this eye, come over here, do the indirect. Okay, then you're going to do this eye. Back up. Why do the indirect? Hopefully you could be looking at, okay, better where you can look at both kind of at the same time, so you don't have to reblind them in that eye, you can kind of do both at the same time. But if not, then you're going to come here and do the direct on this side, then indirect. And you also need to be thinking about, first look for the quick to fire, and if there's not any problems, you don't have to worry about sitting there doing direct. Does that make sense? Anybody have any questions with it? Sure? All right.
Say again. So would you say quick to fire just to see if there's no response or response at all?
Yeah, before you start doing like shine a light all over the place, I mean, if everything works perfectly, there's no need to do it. And again, just remember, you know, if you come lateral to medial, just think about the decussation, right? So if you're actually doing it that way, if you're thinking about the process like this, it's going to be a little bit different. But you need to know that because if you need to stimulate this side, maybe this is for the advanced people, you need to stimulate this side, but you can't use this pathway, but you want to use the light reflex, you can use this side and just come over here laterally and let it decussate. That's it. All right, so let's get in groups and practice doing that.